In this video, I plan to review everything we looked at in Chapter 9. We're going to look at proportional and non-proportional linear functions and all of those things that we learned that go with those linear functions. A function is a relationship between a set of numbers in which every value for x has only one value for y. This can be represented in some different ways. We looked at functions as sets of ordered pairs. And so if you notice on the left, functions only have one value for y for every value for x. If you look on the right, you'll see that the number 3 in the domain is matched with the number 5 and the number 7. So this value for x has more than one value for y. That's why we say it is not a function. Here's a set of ordered pairs that comes from this representation. Notice that every value for x has only one value for y. This set of ordered pairs on the right, if you see the number 3 when the value for x is 3, it has two values for y, 5 and 7. Here's some graphs. These graphs represent functions. We can use the vertical line test, and you'll see that if we draw a vertical line and we could drag that vertical line across the screen, we would see that it would always only touch one point on the line. So a vertical line test shows us that this is a function. On this side, if we have a vertical line, you'll see that it connects with 2 points on the graph. This means this is not a function. If this happens in even one spot, it means it is not a function. So if the vertical line test shows that it only touches 1 point on the graph, it is a function. So every value for x has only one value for y. Then we looked at direct variation or proportionality in 4 forms. Here's an example. There are 98 days in 14 weeks. How many days per week is this? This is a representation of a unit rate. 98 days in 14 weeks can be simplified to 7 days per week. 7 days per week represents the unit rate, 7 for 1. If we look at a table, you'll see that y over x equals y over x equals y over x equals y over x. Remember, y over x. Linear relationships are y over x. So if we look at each set of numbers, we have 7 divided by 1, 21 divided by 3, 35 by 5, and 49 divided by 7. These always equal 7. That's why we call this a constant of proportionality. So k, in this case, the constant of proportionality, equals 7. Here's a graph of this representation. Notice that if we go up 7 over 1, we have a point on the line. Up 7 over 1. We call this the slope. The slope of this direct variation is 7. Notice it's a straight line with a point at the origin. This is true for all proportional graphs. They will always have a point at the origin. The equation for a proportional relationship is y equals the constant of proportionality times x. So days equals the constant of proportionality times weeks. Days is equal to 7 times the number of weeks. 7 days per week. Days equals 7 times weeks. Y equals 7x. When we look at these representations all together, we can see that there's a constant number repeated. Notice that the number 7 is in every situation. That's because this is a constant of proportionality. Also notice that when you're looking here at the equation and we want to know what does y represent, y is seen here in our table as days, and it's also seen here in our graph as days. So that's why we know that when we replace the letter y, we're going to put the word days there, okay? If we look at the value for x, notice that in our table, x represents weeks, and on our graph, x represents weeks. This is why we use the variable for weeks on this side of the equation. Okay? Here's slope from a graph. Well, notice that if the line is pointing from left to right, it's going up. It has a positive slope. Left to right going down, negative slope. Going across, this is 0, fun, remember? So the slope is 0. And y equals 3. When you have a horizontal line, it's written with the variable y equals 3. This slope is equal to 0. In this situation, a vertical line is undefined because the denominator will be 0, and x equals 2. X equals 2. If we find slope from a graph, we find 2 clear points on the line. Clear points are corner points, or points where the lines on the graph paper meet. So there's one, and here's one. Next, we look at the rise. Are we going up or down from left to right? We're going down, down 1. Then we go over 2 to get to the other point. Down 1, over 2. Notice this repeats. Down 1, over 2. It's a constant rate of change. Down 1, over 2. In this example, we have a proportional relationship. Notice that our line crosses the origin. Here at 0, 0, we have a point. Therefore, we know that this is in the form y equals kx, or y equals negative 1/2 x. That's how we would write this equation. In this example, the slope is 3. We go up 3 over 1, up 3 over 1. However, where does this line cross the y-axis? This time it crosses at the number 6. The y-intercept is 6, and it has a slope of 3. When we write an equation that does not go through the origin, we use the form y equals mx plus b, where m is the slope and b is the y-intercept. So we write this as y equals 3x plus 6. This is not a direct variation because it does not cross through the origin. It does not have a point at 0, 0. Here's another situation where it is not a direct variation. The slope is up 1 over 4. So when we write this equation, we look at where does it begin on the y-axis. This is our y-intercept. The y-intercept is 2. So the y-intercept is 2 and the slope is 1/4. So when we write the equation, we say y equals 1/4 x plus 2. So when we have a non-proportional relationship, we must add the y-intercept to our equation. We can also find the slope from a table in a non-direct variation. This is not a direct variation. This is not proportional. So we look at the change in y over the change in x. So let's look at the numbers on the bottom. From 3 to 6 is plus 3. All of these have a relationship of adding 3. The change in x is always plus 4. So we see that the change in y over the change in x equals 3 over 4. The slope equals 3/4. We can also find the slope from 2 points. This is found with the change in y over the change in x. So y2 minus y1 will equal over x2 minus x1. So here's 2 points, 3, 5 and 10, 11. So let's start with y minus y. We're going to have 11 minus 5 in our numerator. Next, we're going to do x2 minus x1. So in the bottom here, we're going to have 10 minus 3. So we find that our slope equals 6 over 7. The slope of the line can be found from 2 points by taking y2 minus y1 over x2 minus x1. Change is represented with subtraction in math. In this slide, we're comparing proportional to non-proportional lines. Notice proportional lines have a straight line that go through the origin and the y-intercept is 0. In this case, there is still a straight line, but the y-intercept is not 0. The y-intercept is 6. This is the equation for this line is y equals the constant proportionality times x, which is like saying the slope times x. So y equals 7x. On this line, the equation is y equals the slope times x, but this time we have to add the amount that it starts with at the y-intercept. So we say m is the slope and b is the y-intercept. So this equation is y equals 3 over 2x plus 6. You see from our graph that the slope is 3, up 3 over 2. 3 over 2 is our slope, up 3 over 2. Here's tables. Let's look at how they're different. Proportional tables always have a relationship where the value for y divided by the value for x is a constant. 8 over 1, 40 over 5, and 56 over 7 all equal 8. These points were found on our table. 8 divided by 1, 40 divided by 5, and 56 divided by 7. On the right side, you'll see a non-proportional relationship does not have this. 5 divided by 1 is 5, but 8 divided by 2 is 4. So a non-proportional table will not have this relationship of y divided by x. However, if you look here, so this we call the constant proportionality on the left with the point at the origin. If you look at the non-proportional table, you'll see that the change in y over the change in x is a constant. 2 over 5 is 3. 2 to 5 is plus 3. From 5 to 8 plus 3. From 8 to 14 is plus 6. On this side we have plus 1, and plus 2. If we divide these numbers, 3 over 1, and then on the bottom example you see you get the change in y was 6, but the change in x was 2. This still has a relationship of 3. So the change in y over the change in x is constant for both of these situations. However, a proportional line is the only situation where y over x equals y over x. If we're looking at word situations, we look for a unit rate. A car travels 35 miles per hour. This is just written as miles equals 35 times hours. A person deposits $75 each week. Total equals 75 times weeks. T equals 75W. This could also be y equals 75x, but in this case y would be total and x would be weeks. A plant grows 2 inches every month. Growth equals 2 times the number of months. G equals 2m. A non-proportional relationship has a starting number and a rate of increase. A person starts with $50 and deposits $30 each week. So we have an additional number in this situation. Savings equals $30 per week plus the $50 that this person started with. So S equals 30W plus 50. A fare charges $10 for an entrance and $2 per ride. So in this case, the cost is 2 times the number of rides the person goes on plus $10 for the entrance fee. T equals 2R plus 10. If we graph with x and y intercepts, we can do this by finding what is the value for y when x equals 0. This will give us our y-intercept. So when x equals 0, we can solve for y. We can also find the x-intercept. This is the point where y equals 0. So let's substitute. If we put a 0 here at times for the value for x, this becomes 0. So then we have negative 4y equals 24. If we have negative 4 times negative 6, we get 24. Let's look now at our x-intercept. So this time we're going to substitute a 0 for y. If we do that, this value becomes 0. And we have 3x equals 24. 3 times 8 is 24. So our x-intercept is at 8, 0. If we plot these 2 points on our graph, we can draw a line through them because any 2 points create a line, and we have our relationship graphed for this equation. This equation is in standard form, ax plus by equals. In summary, a function is a relationship where every x value has only one y value. Linear functions can be proportional or non-proportional. Proportional functions have a direct variation where the value of y over x in a table is a constant of proportionality. The graph has a point at the origin, 0, 0, and it's a straight line. The equation is in the form y equals kx. Non-proportional linear functions have a y-intercept that does not equal 0. The equation is in the form y equals mx plus b, where m is the slope and b is the y-intercept. All lines have a slope that can be found with the rise over 1 run, or the change in y over the change in x, or from 2 points we can use y2 minus y1 over x2 minus x1. I hope this is helpful. Thank you for listening.